Somewhere over the White Sea, an American reconnaissance satellite crosses out of the Earth's shadow and into daylight. Below it is the Russian Arctic coast, the mouth of the northern Dvina, and a shipyard the size of a small city, spread along 11 kilometers of gray waterfront at a place called Severodvinsk. The satellite has a very short window, a few minutes at most, before the geometry carries it past the horizon. In those minutes, it will photograph one specific stretch of pier. And on that pier, tied up and going nowhere, sit two of the largest submarines ever built by any nation in the history of the world. Their names are Arkhangelsk and Severstal. Each one is 172 meters long. Each one displaces roughly 48,000 tons submerged, heavier than a Second World War battleship. Longer than 2 American football fields laid end to end. Each one was designed, from the first line on the first drawing, to end the United States of America. And here is what the satellite sees. Running down the spine of each hull, forward of the sail, are 20 enormous circular hatches, missile hatches. Behind each one is a launch tube. And behind each launch tube, for most of these boats' operational lives, sat a ballistic missile carrying 10 independently targeted thermonuclear warheads. 20 tubes, 10 warheads each. 200 warheads on one submarine. But in this photograph, every single one of those hatches is standing open. Not damaged, not blown off, not left open by accident or by neglect or by some collapse of Russian naval discipline. Deliberately opened. Mechanically locked in the open position. Left that way, year after year, through Arctic winters that would seize a lesser machine solid. 20 open holes in the deck of the deadliest submarine ever launched, angled up at the sky, waiting to be photographed. Now, think about how strange that is. This is a country that has spent the last century building an entire state apparatus around secrecy. A country whose closed cities did not appear on its own maps. A country that hid this very submarine class behind a fabricated cover story while it was being built. And that same country deliberately opened its most sensitive weapon system to the sky, so that American cameras, operated by American analysts, working for the American government, could look down inside the missile tubes and confirm that they were empty. The Soviet Union built 6 of these submarines. NATO called them Typhoons. The Russians called them Akula, shark. 3 of them were cut into scrap using money appropriated by the United States Congress. The industrial guillotine shears and the plasma cutters that sliced through those holes were supplied by the United States. The dismantling was verified by American inspectors and American satellites. The 2 on that pier followed. Scrapping began in July of 2022. By 2024, they were gone. So this is not really the story of a submarine. It is the story of the single strangest transaction of the 20th century. A weapon built to annihilate a nation, paid for, dismantled, and inspected by the very nation it was built to annihilate. And by the end of this, you will understand exactly why Russia agreed to it, and exactly why those hatches had to stay open. Subscribe moment, woven after beat 2, approximately 10 o'clock. A quick word before we go inside the hull. Almost everything in this film comes from the documented record. Declassified American program contracts, Russian shipyard schedules, treaty verification protocols, and the published accounts of the men who actually sailed these boats. Where a figure is disputed, I will tell you it is disputed, rather than pick the number that sounds best. That takes weeks of reading per film. If you would rather have the record than the rumor, subscribe, and leave a like on the way past. It genuinely decides whether the next one gets made. Now, 1972. A design bureau in Leningrad receives a problem that nobody knows how to solve. To understand why the Soviet Union built something this enormous, you have to understand what the Americans had just done. In the early 1970s, the United States Navy began work on a new class of ballistic missile submarine, the Ohio class, and a new missile to go inside it, Trident. The numbers were what mattered. 24 launch tubes per boat, solid fuel missiles with intercontinental range. A submarine that could sit in the middle of an ocean, thousands of kilometers from anything, and still hold the entire Soviet landmass at risk. For Moscow, this was not a competitive problem. It was an existential one. Soviet ballistic missile submarines of that era had to sail out into the Atlantic to bring American cities into range. That meant running the gauntlet, past NATO sonar arrays laid across the seabed, past patrolling American attack submarines, past maritime patrol aircraft. Soviet planners understood perfectly well that in a real war, a great many of their boats would simply never make it to a firing position. So the answer had to do two things at once. It had to carry a missile with enough range that the submarine never needed to leave home waters. And it had to be able to survive in the one place NATO could not easily follow: under the polar ice. The design work began in 1973 at the Rubin Central Design Bureau for Marine Engineering in Leningrad, under a chief designer named Sergei Kovalev. Kovalev is not a famous name in the West. He should be. Over his career, he was responsible for the design of a very large proportion of the entire Soviet ballistic missile submarine fleet. He was twice named a hero of socialist labor, and he was handed in 1973 a genuinely brutal engineering problem, because the missile came first. Soviet solid propellant chemistry lagged behind American work by a meaningful margin. To get the range the mission demanded, the R-39 missile had to be physically enormous, roughly 16 meters tall, around 84 tons at launch. For comparison, the American Trident I missile of the same era weighed around 33 tons. So the Soviet missile was more than twice the weight of its American counterpart to do broadly the same job, and the requirement was 20 of them per submarine. Kovalev's bureau ran the arithmetic and arrived at an answer nobody wanted to hear. To carry 20 missiles of that size, protect them under ice, and keep the boat survivable, you could not simply enlarge an existing design. You had to abandon the shape of a submarine entirely. What they proposed instead had never been built by anyone. There is a detail in Kovalev's situation that is worth pausing on, because it explains the shape of everything that followed. He was not designing a submarine and then choosing a missile to put inside it. He was being handed a missile and told to build whatever would carry 20 of them. That is a backwards way to design a warship. In almost every other navy, the hull and the weapon are negotiated against each other. The missile gives up a little length, the hull gives up a little margin, and the two meet somewhere sensible. Here, there was no negotiation. The R-39 was what it was. The requirement was 20. Everything else in the design was a consequence. And when an engineer is given a fixed volume that enormous and told to build around it, something unusual happens. He ends up with space left over. Almost every submarine ever built has one pressure hull. A single sealed tube engineered to resist the crushing weight of water, with everything important living inside it. Project 941 has two. 2 complete parallel pressure holes, each roughly 7.2 meters in diameter, running side by side down the length of the boat like the 2 floats of a catamaran, and then wrapped together inside one enormous outer casing. Bolted into that structure are 3 further pressure capsules, one forward for the torpedo room, one amidships housing the main control room and radio compartment, and one aft. 5 sealed inner holes in total, 19 separate compartments. Nobody had ever built a submarine this way. Nobody has since, and the layout produced consequences that shaped everything else about the boat. The first is beam, 23.3 meters across. That is roughly the width of a 6-lane road. It made these submarines so wide that most of the Soviet Navy's existing submarine bases physically could not accept them. An entire dedicated facility had to be built at Nerpitia Bay just to berth them. The second consequence is where the missiles went. On virtually every other ballistic missile submarine in the world, American, British, French, and every other Soviet class, the missile compartment sits behind the sail. It is the most obvious identifying feature of the type. On Project 941, all 20 tubes sit forward of the sail, in the trench between the 2 pressure holes. There was a hard reason for that. The R-39 was so tall that mounting it conventionally would have required a hull with an absurd vertical profile. Slotting the tubes into the valley between 2 parallel holes solved the geometry, and it put the missiles inside a protective corridor of structure. It also meant that if a missile ever detonated in its tube, the explosion would happen in the space between the 2 holes, forward of the crew, forward of the reactors. Remember that. It becomes important later. The third consequence was ice. The whole strategic concept depended on hiding under the polar cap. But a submarine hiding under ice is useless if it cannot get through the ice to shoot. So the top of the hull was reinforced. The sail was armored and given a rounded, hardened cap. The forward hydroplanes were made retractable so they would not shear off on impact. The resulting machine could surface directly through pack ice, reported at up to 2.5 meters thick. Not maneuver around it, not find a lead in it, come up through it, vertically, by main force. Construction was assigned to Sevmash at Severodvinsk, the only yard in the Soviet Union with a building hall large enough. Even then, a new hull had to be built. The lead boat, TK-208, was laid down in 1976. She was launched in 1980 and commissioned in December of 1981. 5 more followed, 6 in total. That was the entire class. NATO assigned it a reporting name, Typhoon. The crews who sailed them called them something else entirely, Akula, shark. And a shark is exactly what the Soviet Navy had built. Because these boats were not designed to hunt, they were designed to wait. 2 more things belong in the specification, because they explain how the boat actually lived. Power came from 2 pressurized water reactors, each rated in the order of 190 megawatts, driving 2 shafts through steam turbines. Submerged, the class was capable of something in the region of 25 knots, genuinely fast for an object of that displacement. The outer casing was covered in anechoic tiles, a rubberized coating meant to absorb incoming sonar pulses and damp the noise escaping from inside. And there is a counterintuitive point about the size that Western analysts noted early. You would assume the largest submarine ever built would be the easiest to detect. In practice, the enormous internal volume let Soviet engineers do something impossible on a cramped hull: mount noisy machinery on multi-stage rafts and isolation mountings, floating the equipment inside the pressure hull instead of bolting it to the structure. The Typhoon was reported to be markedly quieter than the Soviet classes that came before it. The size was not only a burden, part of it was the point. Operational diving depth was in the region of 400 meters. Crew complement, around 160. The strategy these submarines existed to serve had a name in Western analysis: the Bastion. The idea was straightforward and rather chilling. Rather than sending its missile submarines out into contested ocean, the Soviet Navy would keep them close to home, in the Barents Sea and under the Arctic ice. Inside a defended zone patrolled by its own surface ships, aircraft, and attack submarines. The Typhoons would sit in that bastion, quietly, under meters of ice, doing nothing at all. Doing nothing, in this context, was the entire mission. They were not a first-strike weapon. They were the guarantee that if the Soviet Union were destroyed, the destruction would be mutual. A retaliatory reserve, a promise parked under the ice that there would be no such thing as winning. Which raises a very practical problem. If your weapon system's job is to remain hidden and inactive for months at a time, what happens to the 160 human beings living inside it? Soviet naval planners took that question unusually seriously. And the answer is the detail that makes these submarines famous. Because of the Catamaran layout, Project 941 had something no other submarine class had ever had: spare volume. So they filled it. The boats were fitted with a sauna, finished in wood. A small swimming pool, filled with fresh or heated seawater, reported at roughly 4 meters by 2. A solarium with ultraviolet lamps to counteract the effects of months without sunlight. A gymnasium. A lounge with a live aviary. Songbirds kept aboard a nuclear ballistic missile submarine, 300 meters beneath the Arctic ice. Officers had cabins. Enlisted men had berths in 2- and 4-man compartments, rather than hot bunking in a torpedo room. Western officers who later toured these boats described the interiors as feeling less like a warship and more like a hotel that happened to be submerged. It is easy to hear that list and treat it as a curiosity, a bit of Soviet excess. It was not. It was a calculation. If you intend to keep a crew sane, alert, and psychologically capable of executing a launch order after 80 days in the dark with no natural light and no contact with the outside world, then the swimming pool is not a luxury. It is part of the weapon system. Everything aboard that submarine, the sauna, the birds, the ultraviolet lamps, existed to keep 160 men functional enough to do one thing on one day: turn 2 keys. And what those keys unlocked is genuinely difficult to hold in your head. It is worth being concrete about what a patrol actually was, because the reality is stranger and quieter than the drama suggests. A boat would slip out of Nurpicha Bay, drop below the layer, and move north into the Barents, or under the ice. And then, for something in the order of 2 to 3 months, it would do almost nothing at all. No radar, no transmissions, contact with the outside world limited to receiving one-way traffic on very low frequency, listening, never speaking. 160 men, in artificial light on an artificial day-night cycle, breathing recycled air, hearing nothing but ventilation and the sound of their own machinery. Nobody aboard would know if a war had started, unless the message arrived telling them it had. The Soviet Navy took the human cost of that seriously enough to try something that sounds almost impossible. In 1987, TK-12 Simbirsk carried out a crew rotation while on station in the Arctic, swapping personnel in the high north rather than returning to base, so the submarine could hold its position while the men aboard it were exchanged. Think about what that implies. The boat was considered so valuable in position and so difficult to replace on station that it was easier to move 120 men to the Arctic than to bring the submarine home. The machine stayed. The people were the consumable part. The weapons system was designated D-19. The missile inside it was the R-39, known in Western reporting as the SSN-20 Sturgeon. 3 stages, solid propellant, roughly 16 meters tall, around 84 tons at launch. Each missile carried up to 10 independently targetable re-entry vehicles, each in the range of 100 to 200 kilotons. Let me put that in a frame you can actually feel. The weapon that destroyed Hiroshima was about 15 kilotons. A single R-39 carried up to 10 warheads, each of which could be, at the upper end of the estimates, more than 10 times that yield. And each submarine carried 20 of those missiles. 200 warheads, 1 hull, 1 crew of 160 men. 1979 estimates, and later Western assessments, put the range of the R-39 at something in the order of 8,000 kilometers. That number is the whole point of the design. From a firing position in the Barents Sea, or from beneath the ice north of Russia, a Typhoon could reach the continental United States without ever entering waters NATO could effectively contest. And it went further than that. These submarines did not have to be at sea at all. The D-19 system could be fired from alongside the pier, tied up, in harbor, sitting in its own base, which meant that even a submarine under repair, even one going nowhere, remained a live strategic weapon. The tubes were arranged in 2 rows of 10, running forward of the sail, and firing was not a matter of 1 missile at a time. In salvo mode, the boat could put missiles into the air in rapid sequence, a few seconds apart, while remaining submerged. Russian naval sources report that in 1997, TK-20 Severstal carried out a full salvo launch of her missiles under Captain First Rank Bogachev. That claim comes from Russian naval accounts and is not as thoroughly documented as some other events in this film, so treat it as reported rather than established. What is thoroughly documented is what a full salvo does to the submarine firing it. When a comparable Soviet boat, the Delta IV Novomoskovsk, fired all 16 of her missiles in a single salvo in August of 1991, the entire launch took 224 seconds. In under 4 minutes, that submarine ejected more than 650 tons of mass out of her own hull. 650 tons, gone, in under 4 minutes. The buoyancy control problem that creates is severe enough that it took the Soviet Navy 2 attempts and 1 destroyed missile to prove it could be survived at all. So that was the machine. 48,000 tons. 200 warheads, hiding under ice that NATO could not see through, in a bastion NATO could not easily enter, carrying enough yield to end a continent. The Soviet Union built the most survivable strategic weapon in human history. And then, on the 27th of September, 1991, one of them very nearly destroyed itself. One more thing about the launch sequence, because it is the detail people usually get wrong. A submarine ballistic missile is not fired like a shell. The tube is pressurized, and the missile is ejected upward by gas, pushed clear of the hull and up through the water column. And only then, at or just above the surface, does the first stage ignite. There is a reason for that. Lighting an 84-ton solid rocket motor inside a sealed steel tube inside a submerged submarine is, to put it mildly, an unforgiving thing to attempt. cold launch ejection keeps the burn outside the boat, which means that for a few seconds on every single launch, a Typhoon was throwing a missile the weight of a loaded airliner straight up through the water above its own deck, and then compensating instantly for the loss of that mass. Now multiply that by 20. By the autumn of 1991, the country that built these submarines was in the process of ceasing to exist. In August, there had been an attempted coup against Mikhail Gorbachev. It failed in 3 days. What it destroyed was not Gorbachev. It was whatever authority the Central Soviet state still had. Republics were declaring independence. The economy was disintegrating. Nobody was confident about who precisely was in command of anything. Against that background, the Northern Fleet scheduled a routine test launch, a demonstration of continuity, proof that whatever was happening in Moscow, the strategic forces still worked. The submarine chosen was TK-17. Later, she would be named Arkhangelsk. Her commanding officer was Captain Igor Grishkov. A test missile was loaded, an R-39, fitted with inert warheads, no nuclear material aboard. The plan was straightforward. Take the boat into the White Sea, submerge to launch depth, fire, and let the missile fly east to the range on the Chukotka Peninsula. On the 27th of September, TK-17 settled at launch depth and began the pre-firing sequence. The missile exploded inside its tube. 84 tons of solid rocket propellant, sealed inside a vertical steel silo, ignited and burned where it stood, inside the hull of a submerged nuclear submarine. The overpressure blew the silo hatch clean off. The dummy warhead was thrown clear into the sea. The tube burned. And this is the moment where a design decision made almost 20 years earlier in a Leningrad drawing office decided whether 160 men lived or died. Remember where the missile tubes sit on this class? Not behind the sail, forward of it, in the trench between two separate pressure hulls. In a compartment structurally isolated from the crew spaces and from both reactors. The explosion went upward and outward, into the space the designers had left for exactly that possibility. Nobody aboard was killed. Nobody was seriously injured. TK-17 surfaced and returned to port under her own power for repairs. The incident was classified and stayed effectively buried for decades. Captain Grishkov's account of that day only reached a wide audience many years later. But consider what it demonstrates, standing where we are now. This machine was so thoroughly engineered to survive catastrophe that it absorbed a rocket motor detonating inside its own body and brought its entire crew home. Nothing NATO ever built could reliably have destroyed it. Nothing the Soviet Union's own weapons could do to it by accident could destroy it either. It could not be killed by force. 3 months after that missile burned in its tube, on the 26th of December, 1991, the Soviet Union formally dissolved. And the thing that force could not do, bankruptcy did in under a decade. A Typhoon-class submarine was never a cheap object to own. 2 pressurized water reactors, 200 nuclear warheads requiring continuous custody and maintenance, 160 trained specialists, a dedicated base that existed for no other purpose, and a design lifetime that assumed a major overhaul roughly every 7 to 8 years, without which the operational life of the boat collapses from around 30 years to perhaps 10 or 15. The Russian Federation inherited all 6 of them, and inherited essentially no money. Through the middle 1990s, the Russian Navy could not reliably pay its officers. Shipyards went months without settling wages. Maintenance schedules slipped, then stopped. Vessels sat at their moorings with skeleton crews. And a nuclear submarine is not like a tank. You cannot simply park it and walk away. The reactors need monitoring. The fuel needs managing. The warheads need guarding. Doing absolutely nothing with a Typhoon still costs a fortune every single year. Then the missile supply chain fell apart underneath them. The R-39 had a finite storage life, and elements of the Soviet solid propellant industry that supported it now sat outside Russia's borders in newly independent states. A replacement, the R-39 UTTH Bark, was developed to keep the class armed into the future. Bark failed its test program. In 1998, the decision was taken to abandon it and develop an entirely new missile instead, the one that became Bulava, which left the Russian Navy holding 6 of the largest submarines ever constructed, with an expiring weapon in the tubes and no replacement that would fit them. In 1997, 2 Typhoons were decommissioned. In 1996, one had already been written off and sold for scrap for want of funding. By the late 1990s, expired R-39s were being disposed of by simply firing them off. And this is the precise point at which the story stops being Russian and becomes something much stranger. Because Washington was watching all of this very closely. And what Washington saw was not a victory. It saw a collapsing state, in possession of tens of thousands of nuclear weapons, unable to pay the people guarding them. The strategic nightmare of the early 1990s was not a Russian first strike. It was a Russian warhead going missing. It was weapons-grade material leaving a shipyard in the back of a truck because somebody had not been paid in 5 months. In November of 1991, weeks before the Soviet Union formally ended, 2 United States senators, Sam Nunn of Georgia and Richard Lugar of Indiana, pushed through legislation that would become known as the Cooperative Threat Reduction Program, Nunn-Lugar. The concept was almost absurdly counterintuitive, and it was correct. The United States would pay, with American taxpayer money, to dismantle Soviet weapons of mass destruction. Not to seize them, not to capture them, to buy their destruction. And that program was about to be pointed directly at the 6 largest submarines on Earth. It is worth putting a number on what Nunn-Lugar actually was, because the scale is easy to underestimate. The program was funded initially at around $400 million a year, distributed across the Departments of Defense, Energy, State, and Commerce. From 1997 onward, it was administered by the Defense Threat Reduction Agency. Its reach went far beyond submarines. It underwrote the removal of Soviet strategic warheads from Belarus, Kazakhstan, and Ukraine. It funded the dismantlement of intercontinental ballistic missiles, strategic bombers, and their supporting infrastructure. It paid to secure or convert nuclear, chemical, and biological facilities. And it put tens of thousands of former Soviet weapons scientists into civilian work, on the straightforward logic that an unemployed weapons designer is a proliferation risk, and an employed one is not. There is a hard-headed idea underneath all of it that deserves to be said out loud. The United States concluded that it was cheaper, faster, and more certain to pay for the destruction of Soviet weapons than to defend against them. Not more moral, cheaper. In 1999, United States Secretary of Defense William Cohen approved the contract to begin dismantling the first Typhoon-class submarine. Under the Nunn-Lugar plan, as it stood at that point, the program was scheduled to eliminate 25 Delta-class boats, 1 Yankee, and as many as 5 of the 6 Typhoons, together capable of carrying over 400 missiles and more than 1,700 warheads. In the end, 3 of the 6 Typhoons were dismantled with United States cooperative threat reduction funding. Now, hold the picture of what that actually looked like on the ground, because this is the part that almost nobody tells you. In the first week of July 1999, TK-202 was towed into Severodvinsk, the same yard that had built her, the same water she had been launched into. The first stage was defueling, pulling the spent nuclear fuel out of both reactor cores, work handled through specialized facilities and managed under international safeguards. That work alone dragged on. By June of 2002, Sevmash was reported to be defueling TK-202's 2 reactors. Then came the cutting. And the tools that did the cutting were supplied by the United States of America. Heavy industrial guillotine shears, plasma cutters. Equipment provided through the Cooperative Threat Reduction Program, specifically to eliminate missile silos and hull sections, and specifically so that the elimination could be verified against treaty obligations. Sit with that image for a moment. A Russian shipyard worker at Severodvinsk in a padded jacket against the Arctic cold, standing on the deck of the largest submarine ever built. In his hands, an American-funded plasma torch. Beneath his boots, the missile tubes that were aimed at his grandchildren's enemies. And the wage that pays him for that shift is drawn, ultimately, on the United States Treasury. The sequence was methodical. The missile compartment was cut out first, because the missile compartment was the entire strategic point of the vessel. 20 tubes sliced from the hull, opened and destroyed. Then the hull itself was reduced in sections. The reactor compartment was cut free as a sealed unit, plugged and set aside for long-term storage. TK-202's scrapping ran from around 2005 to 2009. TK-13's was completed roughly between 2007 and 2010. 3 of the 6 largest submarines ever built, unbuilt, in the yard that had built them, by the men who had built them, with tools bought by the country they had been built to destroy. It is worth being clear about why the United States did this, because it was not charity and it was not humiliation. It was the cheapest strategic bargain in modern history. Building an American weapon capable of reliably killing a Typhoon at sea would have cost vastly more than paying a Russian yard to cut one up on a pier. And unlike a weapon, dismantlement is permanent, verifiable, and cannot miss. Which brings us to the word doing the heaviest lifting in that sentence. Verifiable. Because 3 submarines were now scrap. But 2 were still floating. Put a frame around the economics. Because this is where the whole thing stops sounding like generosity and starts sounding like what it was. Under the plan as it stood in 1999, the submarine dismantlement effort was expected to remove something in the order of 1,200 nuclear weapons from operational systems. 1,200 warheads taken off the board for a program running at a few $100 million a year across every activity it funded. There is no weapon system in the American inventory that delivers that. There never has been. A single ballistic missile submarine of the United States Navy costs several $billion to build. And at the end of all that expenditure, it can only threaten a target. It cannot remove one. Dismantlement is different in kind, not just in degree. A destroyed missile tube does not need to be defended against again next year. It does not require a carrier group to be maintained near it. It does not have a bad day and launch by mistake. It is simply gone, permanently, and both sides can see that it is gone. There is one more layer to this that I find genuinely difficult to sit with. The men doing the cutting at Severodvinsk were, in many cases, the same workforce that had built these submarines. Sevmash is a company town. Fathers built them, sons cut them apart. Some of the welders who sealed those hull seams in 1979 were still on the payroll when the shears came out. And for a shipyard with almost no orders and almost no money in the 1990s, the American dismantlement contracts were not humiliation. They were wages. They were the thing that kept the yard alive. The United States did not just pay to destroy the submarines. For a period, it was one of the few reliable customers the yard that built them had. TK-17 Arkhangelsk and TK-20 Severstal were not scrapped in the 1990s. Severstal was withdrawn to reserve in the mid-2000s. Arkhangelsk followed. Both were eventually laid up at Severodvinsk, taken off the operational list, stripped of their weapons, and then simply left. For a while, there was genuine hope for them. Proposals surfaced to modernize both boats to carry the new Bulava missile. In 2009, that idea still had senior political support. The arithmetic killed it. Refitting a Typhoon for Bulava meant rebuilding the entire missile section of a 30-year-old hull, and the new Bore-class submarines were already coming. Smaller, cheaper to run, purpose-built for the new missile. There was also a strategic ceiling to consider. Russia's warhead allocation under arms control agreements was finite, and spending a large slice of it on two aging giants made no sense at all. So other ideas were floated. A floating museum, a hotel. It sounds ridiculous, and it very nearly happened. Severstal was briefly considered for conversion into a museum ship or a luxury hotel. It was abandoned for the most ordinary reason imaginable: cost. Nobody could make the numbers work on maintaining 48,000 tons of nuclear-era hull as a tourist attraction. And so, the last two Typhoons in existence were condemned to the yard. But not immediately. They sat at Severodvinsk for years in a state that is not quite alive and not quite dead. Which is where the hatches come in. Arms control agreements between the United States and Russia are not built on trust. They are built on verification, and on a specific principle called national technical means. Each side is permitted to confirm the other's compliance using its own satellites and sensors, and critically, each side agrees not to conceal the things the other is entitled to count. So how do you prove to a foreign government that a submarine tied up at your own naval shipyard is not secretly loaded? You cannot invite them aboard every week. You cannot send them a certificate. You open the hatches, and you leave them open. All 20 missile hatches on Arkhangelsk, all 20 on Severstal, mechanically secured in the open position so that any reconnaissance satellite passing over Severodvinsk on any day of any year could photograph 20 empty tubes and confirm, without argument, that no missiles had been reloaded. Not for a week, not for an inspection visit, permanently. Through the rain, through the snow, through Arctic winters, for the better part of 2 decades. The most secretive navy on Earth, holding its greatest weapon open to the sky so its enemy could see inside. There is something almost ceremonial about it when you stand back far enough. A machine built for concealment, built to vanish beneath ice, built so that no one would ever know where it was, ending its existence in a posture of total, permanent, deliberate exposure. It is worth explaining why this method exists at all, because it is one of the quiet triumphs of arms control, and almost nobody knows the term. National technical means of verification. The The phrase appears in arms control agreements going back to the 1970s, and it does something clever. Rather than granting each side the right to inspect the other's territory at will, which no sovereign state was ever going to accept, it grants each side the right to verify compliance using its own satellites, its own sensors, from outside the other's borders. And crucially, it comes with a paired obligation. Neither side may deliberately conceal the things the other is entitled to count. That single clause is what turns a satellite from a spy into an instrument of agreement. So, an open missile hatch at Severodvinsk is not a failure of Russian security. It is a signal, transmitted in the only medium both parties trust: physical, visible, unfalsifiable geometry. You cannot lie to a camera about the presence of a missile in a tube that is standing open. That is the whole reason the hatches had to stay that way. Not for a day, not for an inspection, for as long as the hulls existed. In July of 2022, the last chapter began. Scrapping operations started on the final Typhoon hulls at Severodvinsk. By 2024, the work was complete. Arkhangelsk and Severstal, the last two of the 6 largest submarines ever built by anyone, ceased to exist as ships. The lead boat, TK-208 Dmitry Donskoy, outlasted them by serving as the trials platform for the Bulava missile program, testing the weapon that made her own class obsolete. She was retired in her turn. So what is actually left? Sealed reactor compartments in long-term storage. Some hull sections retained at Sevmash. Scattered artifacts in Russian naval museums. Photographs, drawings in an archive in St. Petersburg. And the memories of a few thousand men who served aboard them. 6 submarines. Roughly 40 years from the first keel to the last cut. And of those 6, 3 were dismantled with money appropriated by the Congress of the United States, using industrial cutting equipment supplied by the United States, verified by American satellites. I want to end on the image we started with, because I think it is the truest thing about this entire story. Picture the deck of Severstal on an ordinary gray afternoon at Severodvinsk, sometime in the last decade of her existence. No crew closed up, no missiles aboard, reactors shut down. 48,000 tons of the most ambitious submarine ever engineered, going absolutely nowhere. And running down her spine, forward of the sail, 20 circular hatches. Every one of them standing open. 20 holes in the deck, angled at an empty sky, filling slowly with rainwater. She was designed so that nobody could ever find her. She spent the last years of her life making absolutely certain she could be seen. Not hiding, not resisting, not even sealed. A weapon built to erase the United States, lying wide open, showing the United States its own empty belly, for no other reason than to prove that it was finally, verifiably, harmless. The Soviet Union built a machine that could not be sunk, could not be found, and could not be killed by any weapon its enemy possessed. In the end, its enemy did not need a weapon. It just wrote a check and asked the shark to leave the hatches open. Before the last image, one thing needs saying, because it would be easy to leave this film thinking the Typhoons were a failure. They were not. Not one was ever lost. Not one ever suffered a reactor accident that killed a crew. They operated for decades in the most hostile ocean environment on the planet. They absorbed a rocket motor detonating inside one of their own holes without losing a man. And they did the job they were built for, which was, in the end, to make a war unthinkable rather than to fight one. Judged as weapons, they never fired a shot in anger. Judged as deterrence, they never had to. And their design lessons did not vanish. The Bore-class submarines that carry Russia's sea-based deterrent today inherited a great deal from Project 941. The under-ice work, the survivability thinking, the acoustic isolation. In a whole, less than half the displacement. Were not a dead end. They were the most extreme possible answer to a question that later got a more sensible answer.